Hi, in this video, I will be showing you problem number 11 of chapter 14, section 6. Find the directional derivative of the function at the given point in the direction of the vector v. F of xy equal to e to the x sine y at the point 0, pi by 3 in the direction of the vector v, which is equal to given in this component form, negative 6, 8. So I have given you the hint. Remember to take the unit vector in the direction of v. Before we get to the directional derivative, we will understand what we mean by directional derivative and how it can be written in terms of the gradient vector. So define the gradient vector del f for a function f of 2 or 3 variables. If f is a function of 2 variables, then del f or nebula f or gradient f at xy is given in the component form as fx, fy, the partial derivative of f with respect to x, and fy stands for partial derivative of f with respect to y, which can be written in the ij form, in the vector form, as partial derivative of f with respect to x, I, plus partial derivative of f with respect to y, j. For a function of 3 variables, it is the same. Only thing is we are going to have k components as well. So del f or nebula f or gradient f at xyz is fx, fy, and fz in the component form, where fx, fy, fz are partial derivatives of f with respect to x, y, and z respectively, which can be written as partial derivative of f with respect to xi plus partial derivative of f with respect to yj plus partial derivative of f with respect to zk. This is about the gradient vector. Then what is the directional derivative? How can it be written in terms of the gradient vector? So duf stands for the directional derivative of f in the direction of u. And we are going to write that with the help of del f, the gradient vector f, and the unit vector u, which has components a and b. The unit vector components are a and b. So it is for 2 variables, it is du of f, directional derivative of f in the direction of u, is del f at xy dot unit vector u. For 3 variables, it's del f at xyz dot product with unit vector u. We know that partial derivatives fx and fy are the slope of the tangent line to the surface in the direction of x-axis and the y-axis. But duf is the slope of the tangent to the surface in the direction of u. U can be any vector, any direction. But u in particular stands for the unit vector, but it can be in the direction of v. So now let's see what are given in our problem. F of xy is given, which is e to the x sine y. Then the point at which we have to find out the directional derivative is 0, pi by 3. The direction in which we have to find out is negative 6, 8. So let's first find del f, which is the gradient vector at xy. So which has components fx and fy, which are partial derivatives. In order to do partial derivative with respect to x, you have to keep y as a constant in the function and then differentiate with respect to x. In order to do fy, you have to keep x as a constant in the function f and then differentiate with respect to y. So if we do that, f sub x would be e to the x sine y, and f sub y would be e to the x cosine y. So del f at xy in the component form is e to the x sine y I. In the vector form is e to the x sine y I plus e to the x cosine y j. So del f at 0, pi by 3, that's a point given in our problem. So we are going to replace x with 0 and y with pi by 3. If we do that, it is e to the 0, which is 1, sine pi by 3i, plus e to the 0, which is 1, cosine pi by 3j, which is root 3 over 2i plus 1 half j. Now del f at 0 comma pi by 3 is this, root 3 over 2i plus 1 half j. Next, we have to find out the unit vector in the direction of the vector negative 6, 8. So if you divide the vector by its length, the length of the vector, what you get is a unit vector, which is a vector of length 1. So unit vector u is negative 6 comma 8 divided by square root of the length, which is square root of negative 6 x square plus 8 square, which is negative 6, 8 divided by square root of 36 plus 64. So in the denominator, we have square root of 100, which is 10. So unit vector is negative 6 comma 8 divided by square root of 100, which will be 10. So which is negative 6 by 10, 8 by 10 in the component form, which is on reducing, we get negative 3 by 5, comma 4 by 5. That is a unit vector. So in order to get the required directional derivative in the direction of v, all we have to do is the dot product of the gradient vector with the unit vector that we found. So du of f at 0 pi by 3 is del f at 0 comma pi by 3 dot the unit vector u. So it is root 3 over 2i plus 1 half j and dot product with negative 3 by 5i plus 4 by 5j. In order to do the dot product, you have to multiply the corresponding components and add. So it's root 3 over 2 times negative 3 by 5 plus 1 half times 4 by 5, which is equal to negative 3 root 3 plus 4 divided by 10. Hope this video helps.